This is the second part of the electrochemistry topic. Okay, we know that there are two types of the electrochemical cell. Okay, the first one is the voltaic cell that we have discussed. Okay, and then this is the second part, which is the electrolytic cell. Okay, so in this part of the electrolytic cell, it is divided to two parts. Okay, two smaller parts. Okay, in which the first one is the qualitative analysis of the electrolytic cell, and then second part is the quantitative analysis. So you know that, okay, when we are using the term of the qualitative, it is about either it is present, so it does not present, or what will be the product. So basically in this qualitative analysis, we will predict what will be the products of the redox reaction that is happen at the electrodes of the electrolytic cell. Okay, and when we move to the second part of this quantitative analysis of electrolytic cell, okay, we will apply Faraday's law. This is when we start to calculate, okay, what is the mass or what is the mole of the product that is produced from the electrolytic cell. Or if let's say we have a mass of the product that is produced, then we can calculate how much current, okay, or what is the energy and so on. Let's look at to these figures. We have seen this before. Just to refresh back, okay, and to look at back what's the difference between the electrolytic cell and also the voltaic cell. So what we have here in the at my left, okay, we have a voltaic cell. It is a reaction between tin SN with the copper. So we have a SN half cell with the copper half cell. So I want you to look at to your standard reduction potential. Please search what is the E naught for the SN and also E naught for the copper reaction.
Negative 0.1.
It is a
Yes.
positive 0.34. Be careful. There are two coppers reduction equation there. The first one is the Cu plus, okay, and then turns to, sorry, Cu2 plus turns to Cu plus, and second is Cu2 plus turns to Cu solid. See, our system here, okay, our half cell here is from Cu2 plus turns to Cu solid. So we are using the second one with the E naught value of 0.34. Okay, so from this figure, we observe that Sn, okay, with the more negative value, the E naught is more negative, then it turns to the negative electron in this voltaic cell. Okay, and the more positive the value, it will turn to cathode. It turns to cathode of the half cell. Then when we calculate the E naught cell, okay, just now is the E naught half cell. Okay, when we calculate the E naught cell, it will be the E naught of the cathode, which is positive 0.34 minus negative 0.14. So that we will get the E naught for cell, the whole cell will be positive 0.48 volt. So when we have a E cell or E naught cell that is positive, we know that this reaction occurs spontaneously. Then that is why this cell is a voltaic cell. Okay, so what happened at the anode is the oxidation when the Sn turns to Sn2 plus. Okay, and then at the cathode, copper 2 plus reduced turns to copper solid. Okay, so if you look at to this half cells, these two half cells, okay, after the reaction, at the end of a reaction, we will observe that, okay, the electrodes of tin, okay, will become thinner later. Okay, because the Sn turns to Sn2 plus. Okay, as for the copper half cell, we will observe that the blue color of the copper ion, okay, our electrolyte, okay, will become paler. Then it will make this electron become thicker. Okay, so that's what happened. Okay, if we have this. Now, if we move to the second figure, this is actually the electrolytic cell in which we still have the same electrode, the same house cell between tin and also copper. The difference is just, okay, now the tin become cathode. Okay, the cathode is always have a reduction reaction. Okay, so instead of the reduction occur at the copper, now the Sn undergo reduction because the cathode is here and then the copper half cell become anode. Okay, if we calculate cat minus N, okay, then we will get negative 0.48. Okay, therefore, okay, this reaction Sn2 plus turns to Sn solid and then the copper turns to copper 2 plus, okay, which is the opposite reaction from what we have in the voltaic cells. Okay, this reaction as the overall reaction will not occur spontaneously. Okay, from the E naught calculation because it is negative. But if we want this to be happen, we want the copper to be oxidized. We want the Sn to be reduced. Okay, so that we will get this overall reaction. Then the external source of the energy need to be provided. So the negative terminal of the power source will connect to the negative electrode. Okay, or the negative end of the cell. Then the positive end of the power source or the positive end of the battery will connect it to the positive terminal of the cell. Okay, because we said that this is our cell, our electrolytic cell. Okay, that's how we memorize it. The negative of the battery connect to the negative terminal. Okay, and then the positive terminal of the battery will connect to the positive end or the positive electrode of our electrolytic cell. Then the process will be opposite to the voltage. Okay. Next, let's look at to the electrolysis. This is actually the process that is happened in the electrolytic cell. Okay, in which the electrolytic cell is the apparatus that carry out the electrolysis process. Okay, this is the apparatus that carried out this process. And what is this electrolysis? It is actually the splitting process of a substance by using the electrical energy, and it will decompose the compounds into its element. So we will put in the compound as the electrolyte. Okay, so what happens is this electrolyte then will undergo lysis and then it will turn to their elements. The most common electrolysis, okay, that we have heard before since our school time is the hydrolysis reaction, right? Okay, when we have a hydrolysis of water, we know that the products we are putting in the H2O, right? Then the products will be two gases, which are hydrogen gas and oxygen gas. Okay, now we will look at, for today, we will look at more compounds when they undergo electrolysis. And in this part, the first part, the qualitative part, you need to be able to predict what will be the products at the anode and also the cathode. Okay, there are several factors that will determine the formation of the products. Okay, because you need to identify what will be the product at anode, what will be the product at cathode. So you need to consider there are three factors that will determine the products. Number one is the standard electrode potential, the E naught value that we have in the table. Okay, and then number two, the nature of the electrode. The electrode can be active or it can be inert electrode. Okay, if we have an inert electrode, it should be no problem. It is simple. But when we start to use the active electrode means that it is the components of a reaction. It is involved in that redox reaction. Okay, as what we have here. Okay, we are using active electrode. Okay, because the Sn is also involved in this oxidation reaction. And the copper involved in this reduction reaction. Okay, but if let's say we have a graphite that we use, that is one of the active electrode because the graphite is not a part of that reduction and also oxidation reaction. Okay, and then the last factor that will determine the products is the concentration. Okay, concentration of what? Concentration of the electrolyte. Okay, now there are two types of the electrolyte that can be used. This is the electrolytic cell. Okay, the previous figure is when we separate the two half cells, but this time in this figure, okay, we have only one container for the electrolyte. Okay, they are sharing the same electrolyte in this container. Okay, so there are two types of electrolytes. Either they are pure molten salt, salt that is melt, means that salts that have a states of liquid. Okay, that is the pure molten salts, or the salt that we dissolve in water, so that we have the second type of the electrolyte, which is the aqueous salt. Okay, so that is on the electrolyte. Then look at to the electrode. It can be inert or active, as what I said just now. Okay, and in general, we have to know that, okay, the anion, okay, when we have a salt, we know that the salt consists of the anion and cation, right? Okay, when we have a calcium chloride, for example, CaCl2, we know that the salts will dissociate to two ions, okay, which is the Ca2 plus and also chloride ion. So in general, we have to remember that, okay, the anion, which is the chloride in this case, okay, will go to the anode to be oxidized. The negative ion will be oxidized at the anode. And then for the cation, the Ca2 plus, it will be attracted to the negative terminal, okay, which is to the cathode to be reduced. Okay, so the anion goes to anode and cation will goes to the cathode to undergo reduction. Okay, so in this case, the first example, what we have as the electrolyte is a molten calcium chloride. So when we have a molten calcium chloride, what we have is a Ca2 plus ion liquid and also Cl minus ion liquid. Okay, so we know that this is the negative terminal and this is the negative electrode. So the negative electrode is apa tadi class? Electrolytic cell. It will be what?
Cathode.
Yes, it is cathode. Okay, and then the positive electrode will be anode. Okay, so this is the cathode and this is the anode. Okay, negative terminal, positive terminal. So that the positive ion will go to the cathode. Okay, then what is happened to the Ca2 plus? Okay, the Ca2 plus will undergo reduction at the cathode. So look at to your, if you don't know what is the equation for the reduction, then you can look at to the reaction table. Okay, you can look at to your standard reduction half reactions to look at to the equation. When the Ca2 plus receive the electron, then it turns to Ca solid. Okay, so what will be the products here at the cathode is the Ca solid that will be deposited at this cathode. Okay, at this electrode. Okay, and then now we want to know what is the product at the anode. Okay, so the anode, okay, what happened is the chloride from our electrolyte, the chloride liquid, will goes to this anode, okay, and it will undergo oxidation. Okay, so when it is oxidized, so we have to look at back to that table. Okay, we have the reduction equation, right? So we have to reverse the equation. Okay, so chloride liquid turns to Cl2 gas plus 2 electron. Okay, this is the oxidation equations of the chlorine gas. Okay, then it is because we want the chloride that is undergo oxidation. So kita tengok the table, we reverse it lah. Okay, so the equation will be 2 chloride turns to Cl2 and 2 electrons. So that, okay, what we will have here, okay, what is the product that will produce at the anode is the chlorine gas. So we will observe the bubbles of the chlorine there. Okay, this is how we predict the products at the anode and cathode. Okay, and the most simplest prediction is when we have a pure molten salt. Okay, now the second type of the electrolyte that we can use here is the aqueous solution, right? And we know that the aqueous solution is when we dissolve a salt in water. So let's look at what if we only have a H2O as the electrolyte. Okay, before we have a salt dissolved to it. Okay, so if we have a H2O here, okay, we know that H2O can undergo both. It can be oxidized, it can be reduced. Now, I want you to look at your table here. I want you to search for the reduction of the H2O and also the reduction of the oxygen. Okay, reduction of the H2O and reduction of the oxygen turns to H2O's equation. Okay, one more time. The negative will mix negative. This is our cathode. Okay, and then the positive end will mix the positive end and this is our anode. Okay, jumpa dah. The equation for the H2O's reduction, it is number 1, 2, 3, 4, 5, 6, 7, 8. Tu tak 8? Tu 2, 3, 4, 5, 6, 7, 8. Number 8 from above. It is 2 H2O liquid plus 2 electron turns to H2 gas plus 2 OH minus with the potential negative 0.83. You see that? Okay, jumpa tak?
Yes,
Ya,
teacher.
madam.
Highlightkan equation tu.
So,
Okay, fine. Satu lagi, oxygen's reduction turns to H2O. Oxygen's reduction turns to H2O. It is the equation number 1, 2, 3, 4, 5, 6. Okay, daripada bawah. Okay, yang saya highlight tu. Okay, so you have to remember these two equation as possible. Okay, as possible to memorize it, but the table will be given. But please, we will always use it. Okay. So we know that this is a electrolytic cell, right? We know that if it is a voltage cell, okay, the more positive one will be reduced, right? Which is the one 1.23 tu, the positive 1.23 is supposed to be reduced. And then the one that is negative is supposed to be oxidized. That is if we have a voltage cell. But remember that this is the electrolytic cell. It will be opposite to that. Okay. So, what is happen if when we have a H2O here, okay, the oxidation will happen at anode. Okay, we know that. Okay, so the oxidation of the H2O will goes to the anode and then it will undergo oxidation. Then it will turns to oxygen gas for H plus and for electron with the E naught of positive 1.23. Okay, so that the products here at the anode will be oxygen gas. Then what will be the product at the cathode? Okay, the H2O molecules will goes to the cathode. Okay, and then it will undergo reduction there. So this is the equations of the reductions of the H2O. H2O plus 2 electron, then the products that we can observe, then we can collect is the hydrogen gas. Okay, so these are the two products. Okay, if we have a H2O, pure H2O as the electrolyte. Okay, when it is undergo electrolysis. Now we go to the aqueous solution. Okay, let's start with the sodium chloride. Okay, so when we start with the sodium chloride aqueous, okay, we know that in a sodium chloride in ACl, okay, there are two ions. The cation ion will be Na plus, the N ion will be Cl minus. So we know that this is a negative terminal cat, this is the positive terminal N. Okay, so the negative ion will goes to the positive terminal. Okay, negative ion goes to the positive terminal to undergo oxidation. Okay, so when it is undergo oxidation, okay, the equations we have to refer to the table back. Okay, what is the equation for the oxidation? So it is chlorine plus 2 electron turns to 2 chloride, right? That is for reduction. Since that we know that it is oxidized, so kita reversekan lah the equation. So the equation will be 2 chloride aqueous turns to 2 chlorine gas plus 2 electron. Then we have to list down the E naught together with it, which is the positive 1.36. Okay, so chloride will go to the anode to be oxidized. At the same time, we know that it is aqueous, right? We also have a H2O in our cell. Okay, in our electrolyte. So the H2O also can go to the anode to be oxidized. So there are there is a competition between the H2O and chloride. Which one that will be oxidized? It cannot be both. Kita tak boleh dapat dua products. Okay. Only one that will be produced at the anode and one that will be produced at the cathode. Okay. So we need to consider both possible reaction that can happen at the anode. It's either chloride that is oxidized or H2O that is oxidized. That is why we have to list the equations of a reaction together with the E naught value. Okay, chloride with the E naught value. Then these are two possible reactions at anode. Then at the cathode here, we know that the Na plus can undergo reduction. At the same time, H2O also can be reduced at the cathode. So we have to list down both possible equation. H2O reduced turns to the H2 gas with the E naught of the negative 0.83. This is from the table. You don't worry. Okay. And then, or if the sodium plus that is reduced. So from the table, okay, check where is the sodium's equation. It is number 1, 2, 3, 4, 5 from above. Okay, nombor 5. Reduction, we have a sodium aqueous plus E electron turns to the Na solid with the E naught negative 2.71. Okay, so we have list all the possible reaction. Then we look at one by one. Okay, at the anode. Okay, so we have to remember back the formula okay, when we discussed on the voltaic cell last time, okay, if the value of the E naught is more positive, okay, the more positive the E naught value, then the more readily the reduction to occur. Okay, so when we talk about the reduction reaction that is occur at cathode, now the competition between these two, right? We know that this is an electrolytic cell. Okay, but this is just the competition that is happen at that specific electrode. Okay, so between these two, which one that will be more readily to undergo reduction will be the one that have a more positive E naught. Okay, so we compare between these two, then we'll observe that this is more positive than this. Okay, the E naught for the reduction of the H2O is more positive, or it is less negative than the E naught for the Na plus to undergo reduction. So when it is more positive, then the products at the cathode will be hydrogen gas instead of Na solid. Okay, that is for the reduction. Okay, now for the oxidation, from the standard reduction potential table last time, we know that the more negative the value or the less positive the value, the more readily the oxidation to occur. Okay, or the harder the reduction to occur means that it means that it is more readily to be oxidized. Okay, so now we want to compare between these two, then we need to consider the one that have a lower E naught value to be oxidized. Okay, so between these two, then the lower E naught value is for the H2O. Okay, therefore, okay, if you have a sodium chloride aqueous or dilute sodium chloride, okay, in dilute sodium chloride, then the products of the oxidation will be oxygen. Okay, and the products at the cathode will be hydrogen gas. If we look at to this value, it is quite close. Okay, when it is quite close, okay, that is why, okay, we have complete on this. When we have a concentrated sodium chloride, okay, when we have a concentrated sodium chloride, okay, we predict, okay, because we have list down all the values just now, right? It is for sodium chloride. Okay, we predict that we are supposed to have a oxygen gas and hydrogen gas to be produced, right? From what we have here. Okay, we are supposed to have a oxygen gas and hydrogen gas to be produced. However, when we have a concentrated sodium chloride, just now is dilute. Sodium chloride, kena ingat tu. When we have a concentrated sodium chloride, suddenly at the anode, okay, we have a chlorine gas that is produced instead of oxygen. Okay, then why is the chlorine gas that is produced at the anode? Okay, as for the cathode, it still produce hydrogen gas. Okay, so from the study, okay, then they found that, okay, in order for the gas of hydrogen and also oxygen to be produced from the H2O, okay, the overvoltage phenomenon can happen. Okay, what is the overvoltage phenomenon? Overvoltage means that, okay, during the production of the H2 or O2, or during the oxidation of the H2O or reduction of the H2O, okay, there will be increment of the voltage about 0.4 to 0.6. Means that instead of it is positive 1.23, then increment of 0.4 to 0.6, let's take the maximum. Okay, kalau they increment 0.6, so that it will goes up to positive 1.83 volt. Okay, as for the, it is the same thing that is happened at the cathode. Okay, since that initially the value, the E naught value for the reduction or to produce H2 is a negative 0.83. So increment up to 0.6. So if it is positive, increase positive lah. If it is negative, increase negative. Okay, so 0.83 at another negative 0.6 maximum. It will goes up to negative 1.43 volt. Okay, so now we have the new volt, the new E naught for the oxygen production. So we compare. Okay, when we want to observe or to identify the products, okay, that will be produced at the anode, we look at to the one that is less positive. Okay, So 1.36 is less positive than this. It is more negative than 1.83. Okay, so the more negative or the less positive will be oxidized. Okay, that is why the chlorine gas that is produced at the anode when we have a concentrated sodium chloride. Okay, because it is about competition that is happened there. And then at the cathode, okay, we compare between negative 1.843 after we consider overvoltage with negative 2.71. We know for the reduction to occur, we have to look at to the E naught value that is more positive or less negative. So these two, negative 1.43 is less negative than this, so that H2 will be produced at the cathode. Okay, it is no problem for the cathode. See, even though we don't consider the overvoltage, we can see the large difference between the E naught. Okay, it is for the case of the one that have a close E naught value ni. We have to consider overvoltage, then suddenly, okay, the H2O's E naught is greater than this. It is more positive than this, makes chlorine to be produced. Okay, why in this dilute sodium chloride, instead of chlorine, we have oxygen? Is the overvoltage does not occur? No. Okay, the overvoltage occur as long as we have a aqueous salt, as long as we have a H2O. Okay, because the overvoltage happen every time we want to produce H2 and oxygen. But then why the chlorine that the oxygen that is produced? Why not chlorine? Because this is a dilute sodium chloride. Remember, there are three factors just now, right? One of it is the concentration. This is a dilute sodium chloride. Okay, so that the concentration of the chloride is less. Okay, low concentration of the chloride. So the competition, when the chloride is low, means that H2O is high. The concentration of the H2O is high. Okay, and then their value are almost the same. Okay, so we need to consider the concentration as well.